Okay, so this is me. I'm currently a professor at Dartmouth. I worked in tech for about 11 years before going back to graduate school and falling in love with geography. And one of the things, why I'm focusing on spatial SQL and databases is because I found that actually my background working with databases in tech was immensely valuable to me in my research in terms of organizing data and getting it together and figuring out how to manipulate it. And would see other people dealing with like large files scattered all over the place that they were losing and stuff like that. So I mean, I think it's a useful skill to be able to do, and I'm going to talk a little bit about some other data formats and kind of why I think using a spatial database is a reasonable thing to do. But I want to get a little bit of an idea of your backgrounds. So how many of you are already familiar with SQL databases in some form or another? So maybe something like half of you. And do any of you have any desktop GIS experience? A handful? And do any of you have web mapping experience? A handful less. And just sort of like any programming language. Most of you have some experience with some programming language? Okay. So, so some of the SQL stuff will be a little basic to some of you, and hopefully won't be too advanced for those of you who've never seen it before. But what I'm focusing on is sort of approaching spatial data from a little bit of a different way than a lot of other GIS people do, which is about GUI interfaces and point and click and visualizing it. And I'm interested in visualizations, but often what I'm interested in is coming up with the analysis and making the analysis reproducible. So for me, working with spatial query is a way of doing it, of basically documenting what I've done and being able to like quickly redo it on a new data set, which is a lot harder to do in sort of traditional GIS point and click interfaces. So a lot of my approach to everything is about the idea of there's a lot of tools out there and you use the right tools for the job. And in the open source geospatial ecology, almost everything is built on these building blocks, which are Google OGR, a set of libraries basically for transforming data between different formats. So between the Esri shapefile format and SpatialLite or GeoJSON or PostGIS. GEOS, which is a spatial analysis package that actually lets you do things to slice and dice the geographies and find relationships between them, which is going to be sort of the focus of what we're doing today. And Proj, which is for projection, for taking points on the surface of the Earth and flattening them in a useful and hopefully not terribly misleading way. And all of these different open source tools basically are built on this. So, someone writes a new GIS, they don't write a new set of data translators. They use Google OGR. In fact, if any of you have any experience with ArcGIS, there's a GitHub project now where someone wrote a plugin for ArcGIS, which is not an open source product, but they wrote a plugin for ArcGIS, which also uses Google OGR. So now it can hit all of these other open data sources that previously it had not been able to, or you had to pay a lot of money for like an extra add-on. So these are two databases. All of the functions that we use, like we're going to use functions called StIntersection and StPoint. They're all basically calling GEOS to accomplish what they need to do, or Proj to accomplish what they need to do. QGIS and UDIG, two examples of open source GISs, and then R has a spatial add-on, and that's the tool that I use more for actual statistical analysis. there's a tendency for people to like try to come up with like one package to rule them all, and instead, this is kind of like the thinking about the Unix philosophy. Do one thing and do it well, and then what you do is you build together the ecosystem that you need to get your work done. So there's a bunch of different data sources out there. Shapefiles are incredibly common. This was originated by Esri, which is the company that publishes ArcGIS, but they did release it as an open standard. So other companies have been allowed to view the standard and come up with ways of working with it. Very widely supported, passed around all the time. A lot of times people give you a spatial data set, it's in shapefile, and it's really despicable because it's actually not a file, it's a bunch of files. A shapefile is actually a collection of 5 or 10, maybe 12 different files that have the same base name, and parts of the, part of it stores the spatial data, parts of it store the spatial index, parts of it store the attribute data, and the part that stores the attribute data is DBF, which means that all your column names are limited to 11 characters. It's kind of ridiculous, and I find it a pain to work with, which is why I'm trying to promote, using other data formats such as SpatialLite. So if so how many of you have downloaded data from like New York City Open Data website and used it for your projects? Okay. So if you download any spatial data, you're probably going to have it in like one of 3 formats. One is going to be shapefile. The other is going to be Esri geodatabase. Okay, there's actually 2 versions of that, one which is file-based and one which is Microsoft Access-based. The MS Access-based one, kind of like SpatialLite, has the advantage that you can collect a variety of different spatial data sources in one container, which is kind of convenient. And the other thing that you're probably likely to get from them is, and we're going to see that with the MTA subway station data that we're going to work with today, is just a text file with coordinates in it, and it's not actually yet a spatial table that you can do anything with. It's just a list of coordinates.
What's that called?
Which?
The text file. Is that what it's called?
Just a text file. I mean, literally a text file that you can open up in a like in a browser and in like a text editor, and maybe comma separated, and a couple of the fields are -71 and 40, because that's roughly New York's longitude and latitude. So okay. All right, so let's start taking a look at some of the software. And the first thing that we're going to do is we're going to actually start loading some of the data that we want to work with into SpatialLite GUI. So that's what I'm going to do, is switch to SpatialLite GUI. And you hopefully downloaded all this data or have a bunch of it. And the first thing is, when you first open it, there's actually no database here. Okay, this is nothing. So we're going to create a database. And I'm going to show you kind of a weird way to do it, which is I'm going to click on this icon, which is creating a new empty memory DB. And then once I've done that, I'm immediately going to save it. And I will go ahead and save it to the Dropbox and call it nyc.sqlite. The file extension is arbitrary. .db and .sqlite are kind of common, but you can give it whatever extension you want. Okay? And then after I've created it, I'm going to disconnect from it, and then I'm going to connect to it again. It's a little stupid. The reason why I'm doing that is on my version of SpatialLite, if you just try to create it using, I'll disconnect so I can show you the button. if I just try to create it using this icon, create a new empty SQLite database, it's going to start like writing to the file system and take like 5 or 10 minutes to actually build like the base of this database. And I'm not sure why it does that. It didn't used to. Newer versions have this problem. Windows does not. The Windows version does not seem to have this problem, but the Linux version does. So. If you use QSpatialite, it should be. I haven't typically created one in there, but you should be able to do like almost all of the same stuff in QSpatialite as you can here. Okay. So now, as I said, there's a lot of data out there that's shapefiles, so we're going to start loading some shapefiles. So the load shapefile icon right here, click it, navigate to the data, and we'll start by bringing in the subway routes. Okay, and it's going to ask us a few different things about the data before it brings it in. It's going to ask us to give it a name. And
sorry, which file system was it? PDF?
it's an SHP file. When you use this particular, are you doing it in QSpatialite or in Spatialite GUI?
In Q.
So how many of you are trying to do this?
Spatialite GUI.
You're doing it in Spatialite GUI?
Yeah.
Okay, it should only, I think it's going to default to just wanting to show you the shape files unless you change the drop down.
I have problems to load it.
On which part?
The SHP file,
Yeah.
the file is encrypted or it's not a database.
That's surprising. So you're trying to import it, and
Yes, I choose the SHP file.
okay. So
Should we attach it? Should we choose the option of attaching it instead of
so you should have yes. So you should be connected to a Spatialite database, which basically, if you are, you're going to see that these icons here are all grayed out. And you have the option of disconnecting it because you're connected to one. You don't have that?
I can't connect. It keeps your error.
Okay. Well, yeah, but can you cancel that so I can just see where you are in the okay, so you do have a database open, and which one are you at? You're clicking on that icon? Yeah. Right.
Right?
No, not that one yet. We're doing the subway one.
Yeah, I tried both.
Okay. Okay.
Oh,
So-
I was like, I used attach and finish here.
No. It's not. So right. So it's not a database. It's data that we're importing to the database. Okay. So there's a few options here. You can give the table whatever name you want to. You might want to follow along with what I'm doing because we're going to reuse these names later. And I usually like to preface all of my spatial tables with geo. Column names, I use geom. This is something that is kind of a convention in the PostGIS world. A lot of Spatialite databases use geometry, but why use 8 letters when you can use 4? The charset encoding should be fine. And the other thing that we have to do on every one that we import is we have to specify what the SRID is. This stands for Spatial Reference Identifier. And what that is a code that looks up in a database somewhere information about what the coordinates actually mean. Okay? So, yes?
Which shapefile am I supposed to open?
At the moment, it's hold on. It'll be easier if I just
I have number the subway
It's this one, NYCT subway routes, and then a bunch of numbers.
Okay.
Okay?
And
Dot-
dot
dot SHP. Yeah. So remember, this is one of the reasons why I find shapefiles annoying. Because then you look in the file system and people don't know which one they're supposed to attach to. Usually what you do is you select the one that is .shp, but there's information in all of those related files is also going to be used and get pulled into the database. But it's like annoying to keep track of and understand. And yes?
So how do you determine what SRI you're supposed to use?
Well, you need to know something about what the source of the data is. So at the moment, I'm just going to tell you what the SRID is, and then
But is that dependent on what type of projection they use? Or?
yes,
Okay.
yes, okay. So this data was this data was created by someone at CUNY Center for Urban Research, and he was using some standard census data as sort of his background when he was doing it. So it was created using SRID 4269, which basically means that it's latitude and longitude data, but it's using a North American datum, which means that the mathematical model of the Earth that we're using to create those coordinates is actually anchored to a point in North America, so that we have a reasonable representation of coordinates in North America. Okay? There's another very common latitude and longitude one, which we'll use for some other stuff that we work with, which is 4326, and that is so-called WGS 84, which is an Earth-centered datum. And that was created primarily for use by GPS satellites. So often, if you get a bunch of latitude and longitude coordinates, and you know their latitude and longitude, and the person doesn't tell you anything else about them, then you might guess that it's 4326 because they probably got it from GPS data and just didn't go ahead and bother telling you that. Yes?
How much difference does it actually make? How much error are you talking about?
Using the wrong datum could, depending upon what part of the world you're in, could lead to things being off on the order of tens or maybe hundreds of meters. It really depends where you are. Okay, so again, I'm going to type in 4269. Whoops. I'm going to click with spatial indexes, and I do this for everything that I import because it will make your actual geometric processing faster. And then hit OK. And it happens pretty quickly. Yes?
So you code for like 4 or 5 minutes, check everyone is on the same page?
Yes. Let me show you one thing, and then I won't import another data set. I'll just show you this, and then we'll kind of walk around. So when it's imported, I just want to point out, it's figured out from the data what the primary key is. It's showing with the geom column. There's like a little globe next to it and a lightning bolt on it. The globe means that that is a geometry column, and the lightning bolt means that it has been indexed. Okay? And I can also take a look at the data. If I right-click on that column and hit Map Preview, so this is basically a set of subway routes in New York, as well as the Staten Island Railroad. You can also actually, if I right-click on the table and hit Edit Table Rows, I see all the data that was imported. And if I go to one of the actual geometry fields here and right-click, and hit Blob Explore. That's not that interesting, but the Geometry Explorer will show me the actual shape of that feature. And there's also several different text representations of it, including the so-called well-known text representation. And some of you might be interested in seeing either the KML representation or the GeoJSON representation. So as you can see, all of these representations basically have a series of coordinates that trace the line. Okay? They're just presented slightly differently in terms of where the parentheses and braces and brackets are. And it's stored internally in a binary format. So I will pause there. Yes?
If I wanted to make edits to the shape files, to the lines, could I do it in here right now?
No. What you would have to do, I mean, you could do a couple of different things. One is you could edit it graphically using QGIS. So you could basically turn on editing for a layer and actually drag a point or a vertex in the line to a new place. If you wanted to edit it textually, then what you would have to do is dump this, edit the text file, and re-import it. So you could dump it. You do have an option too, if you right-click on that, of doing a PostGIS dump, and I think that will dump it to well-known text. If not, you could write a SQL script that returns the well-known text, and then and this is, again, just to look at it real quickly, this is the so-called well-known text format, which specifies what kind of geometry is it. This is a multi-line string. I'll explain what multis mean a little bit later. And then there's a series of vertices. Okay, so there's various functions for either taking well-known text and turning it into a geometry, or taking a geometry and dumping the well-known text. So I'll sort of circulate other questions you want to show me. Oh, the preview map you get if you right-click on the geom column in the tree, in the database tree.
Okay.
And hit map preview, I think, is the bottom option. What's that?
I was where you pulled up the blob.
The blob explorer you access by right-clicking on an actual field in the table, and the way that you get the table is by the actual records is by right-clicking on the and choosing Edit Table Rows. Since it is Edit Table Rows, the other fields should be editable, but I don't think you can edit the block directly. I wouldn't try. Yes. You can get it to open at all. Oh, is this a 32-bit Windows? Yeah. Oh, so you're trying to run the 64-bit one. So there should be a file there that's called x86. So you need to run that's called the one that's called x86.
Yeah, it should be. Yeah, I'm old.
It was two separate zip files. So if you downloaded that one, that was the incorrect. Yeah. So if you go back to my Dropbox.
You didn't rename, that's why it's so easy. So this is good, yeah. This one is
oh yeah, you downloaded the whole thing. Yes, that should be in there. Which one is more recent? So click on software. And what's that one? That's probably that says x86. That's the one. Other questions, or should I move on to importing another data set? All we've done is import data set.
yeah, this week's that's what you said, right? This one at first. I saw the same thing, then I did something.
Oh. Okay, so
That's a real good question.
Okay.
Yeah, on stations and 8 rows. Yeah, okay, you know everything. Alright. Oh, okay, okay. Now we should get up. So you first he did because this way that you heard it.
So if you do, for some reason or another, make an error on the import, someone was just asking me this, and you have the table, but you want to, you want to get rid of it, you can just right-click on the table in the tree and hit Drop Table, and it will drop the table. And because it is spatial light, it will also remove the entry from this table, geometry columns. Okay? Because geometry columns is the table that by the Open Geospatial Consortium standard is used in spatial databases to indicate that that table has spatial data. And it tells us some things about it, the name of the table, the name of the geometry column, the geometry type, which is a number indicating whether it's a point or a line, the SRID. So if you go ahead and drop this, it will also remove that entry and keep your database clean, clean and coordinated. Okay. So the next thing I'm going to do is import the other shapefile. This one is the same SRID. This is downloaded from the census. 4269 is the common one. If you download any shape files or spatial data from the census, again, geom. So now we are downloading uploading the other shapefile, which is called TL 2011-36 tracked. And just to unpack this, TL is Tiger Line, which is what the census refers to the name of their spatial data products. I'm not quite sure. I think Tiger was an acronym for something like topologically something or other.
But it's great data.
Yeah. 2011 is obviously the year it applies to, so we're going to be linking it up with American Community Survey 2011 data. 36 is actually the FIPS code for New York State, so this is the New York State Tiger Line file and track level shapes. Okay. Yeah, I would recommend always doing it with spatial index. And again, just to show you what we've done, if I go to look at geometry columns, it now has both of those tables are in there. Okay? All right. Is everyone good with those steps? The next thing we're going to do is just upload some, import some just tabular data, CSVs. Some of it, the census data, is the demographic data that we then want to link to the tracked shapefile so that we have information about specifically incomes in those census tracts. And the other is the the MTA's list of subway entrances. And that is, like I said before, it's just a text file that lists coordinates of the entrances in it, but it's not yet a spatial table. So the icon for that is right here, load CSV, and these are our options. Go ahead and import this one. And kind of the annoying thing about this is they actually, these files don't have a header row. So I have a separate script that actually has the create table statements. But for now, just make sure to uncheck first line contains column names and make sure that it says column separator is comma.
What's the final?
Sorry?
What's the final?
So the ones that we're importing are the one that begins with a G and the one that begins with an E. The G is the so-called geoheader file that has information about the geography, like the name and where it is in sort of a hierarchy, like a tract, what county is it in, what state is it in, etc. The E file is estimates, which in our case it is estimates of household incomes, and the M file is margins of error, and we're not actually going to be working with that, but that's a measure of how good the estimates are.
So it must be the first column. Which CSV files?
This is the G one, G 2011 5 NY. And again, a little bit about the census data. 2011 is the year it applies to. The 5 indicates it is a 5-year average. Do all of you remember the census long form? Yeah. So, the census long form is now gone, right? And what it was replaced with is called the American Community Survey, which instead of being a longer version of the census that happens with the main census every 10 years, is now an annual survey of a smaller population. And they release annual 3-year averages and 5-year averages, but because it's a fairly small sample, you cannot, they're concerned about disclosure. You cannot get the data for the smallest geographies like census tracts, block groups, and zip codes, except for these 5-year averages. The 1-year averages you can only get for population geographies that have like a population, I think, of 60,000 or more. So usually you're talking about like counties or larger.
Yeah.
Okay. That was the geoheader file. I'm going to do the same thing with the estimates file. And again, no header. Make sure you have commas. Hit OK. I'm not bothering to rename the files because we're going to create another table to hold, to hold that data. Could I trouble someone to grab me another glass of water? Would you mind? Terribly. Thank you so much.
Okay, because you have the answer.
Okay. And the last text file that we're going to import is the one called stationentrances.csv. Okay, and this one does have a header, thankfully. Thank you. But again, make sure that you set the column separator to comma and hit OK. That is a smaller table. That came up pretty quickly. And again, we can take a look at that here. Station entrances, and there's a list of all the stations. Now, what you might notice is that the stations actually, the names appear multiple times because it is literally entrances, which means, you know, all of the stations have at least 2 entries, and many of them have 4, and some of them have like many more than that. So we're going to come up with a way to actually extract just the information for a station rather than the entrances. But before we do that, so let's go ahead and actually import the load the create table statements for the census data so that we actually have the census data in a more usable format. Because if we look at the columns that were imported with the census data, it's, you know, not very usable. Col 001, col 002, etc. Okay? Yeah. Okay. So what I did was I loaded, I put some files in the Dropbox called census data structure. Okay. And what that has is a create table statement with the column definitions, and then an insert statement that's going to take all of those ridiculously named columns and insert it into the table that we actually want it in. It would be great if we could use an alter table command to change the column names, but SQLite doesn't do that. If you were working in PostGIS or another, you know, real RDBMS, you could do that. So I'm going to copy, and you have to do this in Spatial-like GUI one statement at a time. Unlike if you're used to other query languages where if you put like a semicolon, then you can issue additional statements. SQLite will silently ignore anything that comes after the first colon. So copy the create table statement, switch over, and basically we're just going to paste it into this window, and we're going to run it. And then if we refresh the database tree, we've created this table, ACS 2011 5-year geoheader. Sorry? The SQL statement is called census data structure .sql. It's in the root of the Dropbox folder. It's not in the data or software subfolder. What's that? Really? I wonder why, since it just worked on mine.
Sorry. Where do you enter that in?
So when you're in SQLite, when you're in, really?
Insert syntax error.
Not insert, I got create table insert.
Okay. When
I got create first.
let me come. I'll come look at that in a minute. So when you're in the Spatial-like GUI, basically this pane here is just it's a query pane. So I actually didn't show this yet. Like the first time I showed it was by pasting in that. But if I do just like a simple select statement here, you know, and since I'll select from station entrances since that's a somewhat small table, and this is another thing that's a little weird about. So you know, this is sort of standard for SQL, is that with identifiers it ignores case. So if I do select star from station entrances, it's going to show me everything in the station entrances table. Okay, so this is just a query pane. All right, what's the syntax error that we got?
So,
Insert.
Oh, okay. Well, so it looks like you copied in. If it gave you an insert syntax error when you pasted that in, you have to get rid of. So the reason why is you pasted everything in, and it hit the end of the create table statement, and then saw an insert which was unexpected. So you need to delete everything from there down, and just do one statement.
Just the first create table, not
Yes.
the second one.
So,
Just the first one.
Yeah, we're gonna do.
Section by section. Make sure the first create runs and copy the insert.
There's.
one through that does syntax error.
Yeah, I understand. Because it's-
You had a different one, or
Yeah, I didn't hit more. This is my quiz thing.
yeah.
And I try to run it.
Near Ren. You go to the top. Oh, no, that's not, that's right. Makes sense. You're correct. No, but it's not telling me which one. Can you go to the bottom again? Is it possible something else got stuck in there that should have been there? I don't know why since it's running on other people. You might, do you want to just try copying it again from the file? Maybe there's extra line picked up or something? I don't know.
Yeah, it's a little weird, yeah.
Getting this.
You got it also?
Around section by section.
Alright, let me see. So the table has to be created.
I want to run the create instead. This table is already.
Oh, okay, so there that is. So now, so the table is created, so now try running the insert.
Yes, I run it by section by section. I run create first.
You just put it in this box.
I select this one because
Is anyone getting it to run successfully? Yes?
Yeah, one at a time. Create, then insert, create, then insert.
Yeah, so Vivian did the create, but then when she tried to do the insert, she's getting an error, an unspecified error. Has anyone got it to work on the Mac? You have? You're on the Mac also.
how wrong?
Wait, that says Lenovo.
Do you guys want that?
Yeah, no, I didn't.
I got a syntax
Yeah, I'll give like a around. It's not an error. It's not an error.
Okay, you want to see if you can figure out what's happening?
You can't keep doing it.
May I ask a question? I don't think user of SQLite.
That's not an
I
error.
never use Anthos.
Yeah.
So hoping that
Yeah.
R
Yeah.
or recognize. Does the specialized
Let's go back.
run to the command line?
I run section.
Yeah.
Okay.
There's a spatial light.
Okay, got it.
Yes, I mean, half the rows in it now. You might have multiple runs.
Okay, thank you.
So, let's go back again. Just want to see where you already did that, right? Where you paste the sequences might.
Okay.
What
Yeah,
happens
so
when you the insert?
what?
Is the item photo going to keep you do the same insert over and over again?
Yeah.
Will be a problem?
Oh, yes, because there's a primary key in the table.
It would throw it out, right?
Yeah.
It'd be fine.
It wouldn't insert it. It would refuse to insert it
It'd be
because of the
fine.
primary key violation.
Yeah, it'd be fine.
So did you do it? You did it once successfully, and then you were trying to do it.
You know what
again?
happens when you run it? It
Yeah.
says this is not an error,
Yeah.
but it looks like an error.
Yeah. Okay.
It's an insert, you know, and you said that.
Right. Okay. Yeah, so someone was asking where, just to watch again what I'm doing here. So this is the file that I'm copying the statement from. Copy, switch to the GUI, and then this pane in the upper right is where you do the SQL statement. So I'm pasting it in there and then hitting this execute button to run. And it's the way an insert in SQL is structured. It's because I'm not specifying what rows to insert to, it's just going to insert into the rows in the order that they've been defined in the table. And what it's going to insert is the result of this select statement. Okay? And basically, all this select statement is doing is selecting all of the columns from the table that we imported that got stupid names because there was no header. Okay.
So you're only copying the last 2 lines, right, from that file?
There are 4 sections. There's a create table and an insert, and then there's another create table and another insert. I'm doing them in that order. All 4 of them.
Oh, we are going to.
Yeah. So we're doing 2 create tables and 2 insert statements. Okay.
And where are you clicking on the left side? Where do you actually
To run it.
No, on the left side, what file you can't see?
Oh, this table is, this is the one that got created with the create table statement, ACS 2011 5-year geo header.
Where can you see the table? Will you show up?
Okay, so once you've done this, if you've created a new database object using these database commands, it's not going to immediately show up in the tree. All you have to do is right-click anywhere in the database tree and hit refresh, which is the top option, and then you'll see the item. Yes.
How did you deal with the syntax error?
So at first they were trying to run all the statements at once, and so that was illegal. And then the second time they did the insert successfully, and then they were trying to do it again, and that's why. And it was giving them, it was a primary key violation, but it wasn't actually telling them that.
Yeah. I caught across a couple from Dropbox.
So I'm going to move to the next create table statement.
Oh, yeah. Open the hex file. Don't use sticky. Open it now. What did you open?
We're just any text editor.
Text editor. Whatever is on the Mac.
I'm pasting it in. I'm running the create table.
So that must be the actual tab.
And now again, if I refresh the database tree, that table is now listed here.
I was trying to avoid it because the original
Now the end of the table says seek 0056. The way that the census releases the data, it releases the data in sequences, which are supposed to be, like old school spreadsheet width, like they top out at 255 columns, because the actual American Community Survey data set is like 23,000 columns. So it has about, I think the 2011 has 118 sequences, right? So it's just 118 separate tables. They all cover the same geographies, and you link them together through the geoheader using the primary key, the fields that I've defined as the primary key on this. which is STUSAB, which is just a 2-digit state code, and the log record number. Now, for some stupid reason, the STUSAB is uppercase in the geoheader, and it is lowercase in all of the sequences, which is annoying. So we're going to change that now with an update statement. And some of these now should be, I don't know if this, I don't actually, if I know I've actually put this one in there. I have another, it doesn't look like I did. But basically, we're doing, you know, a pretty simple update statement. Whoops.
It's really hard to see from here to the back.
Oh, okay.
Do you want to try using my laptop so everyone can share the screen?
Yeah, sure, I can try.
Even if one bigger.
I'm actually not sure if this, I don't think that this GUI has a way to do that.
We can lower the
I'll type it in. So I'm going to do an update just to change that to uppercase. And it's STUSAB equal upper STUSAB. So is everyone able to read that? Most of these statements, if you have the PDF from the Dropbox, like all of this is in there. So you can see it there. Did everyone get to run that command? Resounding silence.
Is there a way to look into that? Like, it's hard to tell that the things have taken effect. How do you look at the STUSAB
Yeah, so what I would do,
table?
okay, so you can write, and do not do it for the sequence file because it's a large table and it'll actually take a little while to load. You can right click on any table and then choose edit table rows. But what I would do is just do a simple, you can do select star from, and then the easiest thing to do if you don't want everything is limit. If you do limit 100, it will only give you 100 rows. Any 100 rows, there's no order, but it's a simple way to inspect a data set without, without loading the entire one. Okay? And now we can see that the STUSAB field is uppercase. So that will be useful because when we start joining the data, it means we don't have to keep putting an upper command in the join statement. Okay. So once I've done that, I'm actually going to drop these other tables, the ones that I imported, the one called E 2011 blah blah blah, and the one called G 2011 blah blah blah. Okay, so now let's get to some kind of interesting spatial stuff. We've got the station entrances, and as I pointed out before, there's multiple entrances for each, there's multiple records for each station. And what I really want on the map is one. I just want one dot to represent the station for now. Don't care where all the entrances are. So one way to deal with this in SQL is to use the distinct keyword, and distinct will return only rows that are different from each other. So if you end up selecting rows where all of the fields are exactly the same, it will just collapse them down into one row for you. Okay? And if we look through this data set, and I'm going to scroll down to one that I know there's something interesting to look at, DeKalb Avenue. So the station latitude, station longitude, those are the same. What routes are there? B, Q, R, then a bunch of nulls, those are the same. Then we get over to this column, entrance type, and one of them has an elevator, and 3 of them are stairs. Okay? So that's where it's different. And after that, then the data becomes appropriate to the entrance and not the station. And in fact, when you get to the end, there's different coordinates. So there's like an overall average coordinate for the station, but there's also GPS coordinates for each of the entrances. So since we right-clicked on station entrances and chose edit table rows, the nice thing is we got a SQL statement up in this pane that we can work with to do what we want to do. And what we want to do is we want to get rid of the row ID and PKUID, which is another row ID, because those are unique identifiers, and we don't want uniqueness for each row. We want to collapse down the rows that are similar. We're going to insert the word distinct. And then I'm going to go down this list to the one that I said that was the first unusual one, which is right after Route 11. The one that says entrance type or something like that. Okay? And I'm going to delete everything after that. So the last thing it should say, the last column that we want is Route 11. No comma. Get rid of that trailing comma because it's the last field we want. From station entrances, and we're also going to get rid of the order by statement. We don't care about the order. Okay? And if I run this select, and you'll notice at the bottom it says we have 1,862 rows, which means 1,862 entrances in the subway system. Now if I run it, we get a query return with 466 rows. We have 1 row for each subway station. Okay? Now the thing that we want to do is we want to actually go ahead and turn this into spatial data. And we're going to do that with a function called StPoint. Okay? StPoint takes an x coordinate and a y coordinate and returns a geometry. Okay? That's the inside function from this paren to this paren. Okay? That returns a geometry. It does not have to be a latitude and a longitude. And by the way, even though we usually say latitude and longitude, on a Cartesian grid, x comes before y. So when we're doing StPoint, it's x, y, so it's longitude, latitude. Okay? What was I saying? So it does not have to be a latitude and a longitude. I was working with the NYPD stop and frisk data. Those numbers are not in the 40s and 70s. Okay? Those numbers are in the hundreds of thousands and millions because it's in the New York State plane coordinate system, which is measured in feet from a 0 point somewhere to the southwest of New York City. Okay? This is just a convention with state plane coordinate systems so that all the numbers are positive. They pick a point to the southwest of the area of interest, and then all of your x's are positive and all of your y's are positive. Okay? So if you had that data and you wanted to import it, you would have to put in that x coordinate, that y coordinate, and then in order for the geometry to be constructed correctly, you need to tell it what SRID it is. And we wrap this geometry that gets returned, StPoint, which returns a geometry, we wrap it in set SRID and set SRID takes as parameters a geometry, which is returned by this, and an integer representing the SRID. Again, 4326, GPS-based coordinates. New York State plane, which we'll work with in a little while, is 2263. You want to do spatial manipulation of your data in a more precise coordinate system. I shouldn't say more precise. In the best local coordinate system you can. So if we're doing anything within New York City, we're going to use something like 2263 rather than this, because as I'll show you, the geometries look distorted if you zoom into New York using this coordinate system. There is one other thing that I'll mention, which is that spatial light has a function, and I footnoted this in the guide, so you don't have to write it down, you can read it later. But spatial light has a function called make point, which lets you give an x coordinate, a y coordinate, and an SRID, and get the geometry returned all at once. And the main reason I don't use that is because it's not compliant with the OGC, which is Open Geospatial Consortium standard, and because PostGIS doesn't implement it. So there's actually several functions in spatial light which they like to drop this ST underscore, which is required by the standard, and they're trying to make it shorter, but I don't like to remember 3 different syntaxes. If I can find one thing that works across 2 main ones that I'm using and is standards compliant, I'm going to try and use that one. So hence, StPoint, set, SRID, both of them are standards compliant. Yes?
If I'm totally making up my own X and Y, what's the SRID?
You mean if you're not? Is it geographic data, or is it not geographic? Is it just a geometry, like you want to draw pretty squares, or is it actually supposed to represent the place on the Earth?
It's actually a location, but it's not. I don't want to think about it in those terms. Longitude, latitude, or anybody else's coordinate. I want to make them my own.
If you want to make up your own, that will be an exercise. I don't even know how you begin to do that. So if you import something without specifying the SRID, it's going to default to 0, and there's actually a slight distinction between. I think spatial light always defaults to 0, and I can't remember if PostGIS defaults to 0 or -1. Recently, PostGIS introduced, or it might even be in the standard, a distinction between 0 and -1, where one of them is an unspecified but presumed geographic coordinate system, and the other one is just geometries that could be in outer space or something, and like you don't really know. I think that's -1. But if you want to make up your own, then what you probably want to do, like making up your own involves coming up with the transformations and somehow or another getting it to work with the proj package, because then you could actually enter a projection string that the proj package understands into your database, and then whenever you used your made-up SRID, it would actually look to those mathematical transformations that you created, and it would translate to any others that are available. So if you made up a real one, a new projection, then you could do that. In fact, if you wanted to look at it, it's probably all of these codes are actually in this table, spatial refsys. Oh yeah, there it is, undefined Cartesian and undefined geographic lat long. And then all of these others are, named coordinate systems, and this string here is actually a set of transformation instructions, which the proj package that I said all of these open source GISs sit on top of actually uses to translate between these different coordinate systems. Okay. So, all right, where was I? Oh, so that's another thing. This back button takes you back to the last SQL statement. So I'm going to go back to the select distinct that we had and run it again. So now what we're interested in doing is we're actually interested in creating a geometry from this coordinate system. And for good measure, we're going to turn it into a table. And I'm pretty sure that this one yeah, I think I have everything except the create table part. So I'm going to copy this very first statement, and this is in a file again on my Dropbox called spatialsql.sql, and paste it here, and you can see what I just showed you on this other screen is what I've added. Set SRID, set StPoint, station longitude, station latitude, the SRID as geom. Okay? And the only way, and I'm going to modify this because I actually don't have it in the file. At the top, I'm going to type create table, and I called this one geo underscore NYCT station 2011. Do you want me to make that bigger, or?
And what was the file name? What was your story?
The file that it came from is just called station entrances. That's the CSV that was imported. Okay?
Is there a way to define the column type that goes to data type?
I'm sorry?
Is there a special data type for?
Yeah, it's basically it's called a geometry data type.
So is there a way to define the output of the last select, the last column which you select?
Oh, yeah. There is, and so first of all, the functions take geometries and they return a geometry. So the result set will have a geometry. Okay. So the result set is a geometry. We need to do an additional step to register it, which is just adding it to that table that I was telling you about. But what gets returned is already a geometry because that's what that function returns. Okay?
Is that where it says at the end there from NYCT station? That's supposed to be station entrances.
Did I give it a different? Did I mess up the name?
Station entrances, right? No.
Oh yeah.
That's one.
No, right. I might have done this in two separate steps when I was doing the thing. Yes. So that should be the table that's in there is station entrances. Okay. So now I'm going to run this create table. Whoops. Good. There's a syntax error.
Mine is because quotes around station entrance, so it's why that doesn't make
No, quoting the identifier should not be a problem. Create table, geo. Oh, as. Sorry, I forgot the as keyword. Okay. Yes. When you do create table and it's not based on a query, it's just create table parentheses in your column list. When you're creating a table from a query, it's create table as select. So I run that. Again, I'm going to go refresh here, okay? And the table is here, GeoNYCT Station 2011. You'll notice that we have different icons here. This just looks like a table. This one has the cute globe on it, which means it's a spatial table. How do we make this a spatial table? So as I said, we need to insert something into the geometry columns table, but rather than do it manually in Spatial Light GUI, we can expand the column list. And can everyone see this okay? I'm going to go to the bottom column, which is geom, and there is an option here called Recover Geometry Column. I click that, and here I specify the SRID. And again, what I was saying was someone gives you longitude and latitude, and they don't tell you anything else about it. It's probably 4326. Dimensions. It's a little weird. XY. The choices are XY, XYM, XYZ, and XYZM. Okay, X and Y are planar dimensions, right? X and Y coordinates. XYZ means it has a third dimension, which is a physical third dimension. It is altitude. Okay, M is a third dimension, which is a measure. So you could define a point that had measures of, longitude, latitude, and temperature, and that's your M dimension. And you also have the option of all three, so that you have a point that exists in 3D space and has a measure associated with it. And this is XY, and it's just a point. We hit OK. Okay, and at this point, and now, again, we don't have the cute symbols, so I'm going to refresh again, and now we actually see that this is a geometry column. Sorry, that's the wrong one. That this is a geometry column.
What was the geometry type?
Point. The coordinate, the dimensions is XY, and the geometry type is point. And we can also index it, and again, we can do it by right-clicking and selecting Build Spatial Index. You do all of these commands. You do have the option of doing in pure SQL, but and often I do. But for people that have never worked with this before, the GUI just makes it a little easier. And again, what we can do is we can select the geometry column, select Map Preview, and we see a list of all the points. Okay. When I was yes.
What did we create index
On the geometry column. So if you after you click Recover Geometries, then you click and hit Build, Create Spatial Index. Okay. When I was running through this and I tested it, I did the map preview and the map was blank, and I couldn't figure out why. So I actually pulled I viewed it in QGIS, and I basically it was showing me that the extent covered like the entire planet, and I couldn't figure out why. And then I looked into the data and realized one of the points, the longitude was 70 point something instead of -70. So you had a whole bunch of points in New York City and one that was, I guess, in like eastern China or something. So if you right click on any geometry column, the bottom option is Map Preview.
So if it's a three-dimensional,
If it's three-dimensional,